Good morning, everyone. We shall see a simple concept in real analysis. We are looking into the functions of bounded variation. So, before defining this, let's know what do we mean by partition. So, if a comma b is a compact interval. So, why do we say compact? Because it is closed and bounded. A set of points p is equal to x0, x1, x2, etc., xn, satisfying the inequalities. So the first point would be equal to a and the last point would be equal to b, and all of the points in the interior of the interval is called a partition of a comma b. But this should satisfy the inequality x0 is less than x1 less than x2 etc. less than xn minus 1 less than xn. The interval xk minus 1 and xk is called the kth subinterval of P. So we mean by P as partition. And we are also defining what is delta xk. This is equal to sk minus xk minus 1. That means the length of the, that means it's the length of the kth subinterval. So when we sum up all these, we'll be getting answer as p minus a. All the terms gets cancelled. So what is your summation delta xk? It is equal to xn minus x0. We know xn is equal to b and x0 is equal to a. The collection of all possible partitions of a comma b will be denoted by script p of a comma b. Let's see maybe the two types of just a collection of partitions. That is a partition of a compact interval I is a strictly increasing sequence of numbers. Okay. So belonging to the interval I itself, starting from the initial point of I and arriving at the final point of I. Let's see what is a partition of 1, 10. So one type of partition is with a length 1 we are just defining 1, 2, 2, 3, 3, 4 etc. 9, 10. Another type of partition we are defining with the length 2, that is 1, 3, 3, 5, 8, 10 etc. So let's look into this figure. So we have the interval a and b, and b is going to be equal to the first point x0 and b is equal to the last point xn, and we have in between xi minus 1 xi in general, and this is the function. We will be seeing its sum with the use of rectangles. This is often called Riemann-Stieltjes sum. So let's look into more about functions of bounded variation. What is its definition? Let f be defined on a comma b if p is equal to x0, x1, x2, etc., xn minus n, xn as a partition of a comma b. We write delta fk is equal to f of xk minus f of xk minus 1 for k is from 1 to etc. n. If there exists a positive number capital M such that the sum of all delta fk is less than or equal to sum of all modulus delta fk is less than or equal to that m positive number for all partitions of a comma b, then we can say the function f it is said to be of bounded variation on a comma b. This is an example for that. This is the function f of x is equal to x square sine 1 by x. So we can look into the curve. So this is of bounded variation on the interval 0, 2 pi. 0, 2 pi. There are few theorems derived out of bounded variation. First one, if f is monotonic on a comma b, then f is a bounded variation on a comma b. So monotonic implies bounded variation. If f is continuous on a comma b and if f dash exists and is bounded in the interior, say modulus f dash of x is less than or equal to a for all x in the interior, therefore open interval a comma b, then f is of bounded variation on a comma b. Third one, if f is of bounded variation on a comma b, say summation modulus delta f k is less than or equal to m for all partitions of a comma b, then f is bounded on a comma b. In fact, modulus f of x is less than or equal to modulus f of a plus m for all x in a comma b. So these are few results derived out of bounded variation. Thank you.